Hello, everyone. So this is Oliver from Transentis Consulting in Berlin, in Germany. So I'm calling in from Europe. Thank you very much for attending my presentation on automating content management using the Wolfram technology stack. Before I get started, perhaps a few words about my background. So I'm actually a mathematician and economist by training, and I've been using, or my company has been using, Wolfram technology and especially Mathematica now for 10 years, and actually we mostly use it to build business simulations. So that's one of our topics, and actually using it for content management is something that sort of almost came about by chance. I'll say a little bit about that during the presentation. I've spoken at a Wolfram technology conference before in 2015, so that's a while ago now. And I'm happy to be back now presenting on this topic. And the reason this topic is quite important to me. So this is about automating our own content management. So it's not something we did for a client or something like that. So it's something about using Mathematica or Wolfram technology for us internally. And for me, the interesting aspect and something I want to talk about today is, can you use Wolfram technology? So all of us know how well Wolfram technology works within Mathematica notebooks, within the Wolfram world. But my interest was to see, can I bring the Wolfram technology into the run-of-the-mill, everyday computing world? Okay, so I wanted to see how that works out. And so from our perspective at the company, from my personal perspective, that was quite an interesting journey. Okay, so let's get into the content. So why is content management, and why is the task of automating content management a relevant one? Well, first of all, I think there's a strong trend in the market towards what I'd say is API-driven, multi-source, multi-channel content management. So why you used to have, let's say you used to have things like, let's say WordPress, and you have your website or your blog on WordPress, and you edit the data, and you have a front end, and automatically have a display with it. Things are changing quite rapidly, and now content management is turning into a multi-source thing. So you have content management systems, you have CRM systems, you have other systems that have data, and somehow you need to push that data into lots of different channels. And everything nowadays works via REST APIs, so it's API driven, which is both a great opportunity, but also a technological challenge. And so what you need is some kind of glue to put all these APIs together to get data from the sources, transform the data, and push it into multiple channels. And obviously, there's lots of ways you can approach this, but my feeling was that Wolfram technology might actually be a very good fit for this, and actually, to me, it turns out to be an almost perfect fit. And the reason we actually started using it for our website was actually by chance, because I'm not normally on the web development team, so to speak, but someone in the web development team fell out in the last minute, and he was meant to be porting our old blog from WordPress into the new system and writing scripts for that, and he in the last second he couldn't do that, and so I thought, well, okay, let's try and do this using Wolfram technology, because I remembered how well Wolfram language supports reading web pages and scraping web pages, and so we took the approach of porting our old blog using Wolfram technology, and that worked so well that I then sort of thought about how can we use it for other things. Okay, and this is what this talk is about today. So the concrete challenges when we're talking about content management is that content management is going headless. What does that mean? That means that, as I said in the past, you have systems like Joomla or WordPress that they're both an engine where you can put in data, put in your content into the database, but they also have a presentation layer which presents that data or that information, that content to the web. And what's changed is that those two parts have become cleanly separated. So you have so-called headless content management systems, which allow you to enter data in a very flexible data model, but it's not data, numerical data, it's textual data, content, and you have an engine that allows you to enter that in a very flexible data model, and separated from that is how you then present that information to the world. So the presentation layer has been sort of cut off, and that has lots of great advantages, because it means, for instance, that you can keep your content in this content management system, which has a flexible data model, and you can push that content into lots of different channels, let's say into your website, yeah, but both, let's say, the same content can be pushed, let's say, as a web page, but also as a document or as a PDF. You can push the same content to social media sites and so on. And on the other side, the content itself is no longer just coming from the content management system, which used to be a sort of a fairly closed world. It's also coming from customer relationship management systems, I think increasingly from enterprise knowledge graphs. So there's lots of different systems you're pulling the data from and then pushing it into different channels. Okay, and what I'm interested in is in a sense the content generator, the content transformer that takes that content and pushes it somewhere else. Okay, and so the key insight I think here is that because we're talking about APIs and mostly REST APIs where you're pulling the data from, in a sense, that challenge is actually an ETL challenge. So you extract the data, you transform the data, and you load it into some other channels. Okay, and as you probably know, Wolfram language is very good at doing that kind of stuff, and so therefore it's in a sense a natural thing to do to try and use this also for content management. So let's just take a quick look before, and don't worry, I will be getting into code in a second. I'm just looking at the architecture at the beginning. So why is the Wolfram tech stack so well suited to the challenge? Well, first of all, as I already mentioned, you need to pull the data from the source systems, and nowadays, thanks to the drive into the cloud, pretty much everything is API driven, and so you have REST APIs or GraphQL APIs, and they provide data in the JSON format. And as it turns out, Wolfram language has native support for REST calls, so you can speak to any REST API out of the box. You don't need to create your own libraries or anything like that. Wolfram language can do that. Wolfram language has native support for JSON, and as we see, actually very powerful support, and manipulating JSON structures is one of the things you have to do all the time when you're talking about modern content management. And if you have an engine like Wolfram or technology stack like Wolfram that can easily manipulate JSON structures, you can already go a long way. Yeah, and manipulating data structures is also always about using different kinds of patterns to parse the data. And as you know, Wolfram language is very good at doing that. So it's very powerful at what I would call ETL scripting in this context. But also when it comes to transforming data, what I like about the Wolfram engine, it supports generating PDFs, it supports generating Excel sheets. So there's quite a few native built-in formats, so you don't have to worry about finding some library to convert the data into the right output format. In most cases, the Wolfram language has you fairly well covered. And then the next thing is you have the Wolfram engine. So that's obviously been one of the great things over the last years, that Mathematica has evolved into a whole stack of technologies, and the Wolfram engine obviously is one of the useful things of being able to use it as a fairly low cost engine, and that's obviously important, because when you're scaling at a cloud level, you don't want to be spending endless amounts of money on licenses. So you need something that sort of works fairly well in a scalable environment, and the new licensing models offered are actually quite good for this. And then on top of that, you have an interactive notebook environment, which it still is the best thing in my opinion to test and experiment with code and with data is to work in an interactive way, and obviously notebooks are a great way of doing that. So that's why, in principle, the Wolfram tech stack is the right way to go. And so now let's look at what it looks like in detail. Just before we get into the code, perhaps just to explain a little more exactly how, if you're using a headless content management system like we do, how websites are actually generated. So what happens is you have the content management system. In this case, we use Contentful, which is an online service, online content management system, which let's say is running somewhere in the cloud. and you can enter data. You can create your own data model, your content model, and enter web pages, blog posts, whatever structure you want to have. Whenever you make a change, Contentful triggers a webhook and says, look, data has changed. You need to regenerate your website. And obviously, it's up to you to decide if you want to generate the website every time something changes. But Contentful informs you about that. And interestingly, we use a little API function in the Wolfram cloud to pick up that trigger. So in our case, Contentful triggers an API function in the Wolfram cloud and says, look, something's changed. And then the Wolfram cloud, the API function then goes on and triggers our automated build pipeline to regenerate the website. And the build pipeline is running on Bitbucket, which is an online Git service, which has very powerful build pipelines. And that takes all the content, generates the website, and pushes it onto Amazon Web Services and onto S3 as a static site, which is then served via Amazon S3. And the reason we use the Wolfram Cloud for this is simply because, in the end, the API function is probably about 10 or 15 lines of code, which we could then load into the cloud. So there's no way you can, I don't know of any other way you can do that as easily and as quickly as we did it this way, because even Amazon Lambda functions and so on, they take much more effort to actually deploy them. And this literally is, 10 lines of code, which we deployed within a few minutes onto the Wolfram cloud. So that's interesting in itself, that we're already using Wolfram technology to generate our website, and it's been running now for a year, and we've never had a single hiccup there. Okay, so that's the basic setting. So now let's look at, and obviously I can't show you all the code that we built to do all this, but I want to show you some of the highlights of how we do this using Wolfram language. So step one is to retrieve data from the REST API. And as I already mentioned, Wolfram language makes it very, very easy to directly access content management system. And as I said, the content management system we use, Contentful, is running in the cloud. So I load the access tokens, and I've obviously provided this notebook, so you can download this. And I've also provided the data I'll be working with. I haven't provided the access tokens, because that's obviously a secret, but I just want to show you how easy it is to actually pull data from Contentful. So essentially you need a key, obviously, to ensure that not everyone can pull their data. And this is the ID of one of a concrete blog post we have, which I'll be working with as the test data today, okay, for the demonstration. So this is one entry in our content management system, a blog post, which has a particular ID, which I'm now getting via the REST API. And this is the HTTP request. So this shows how in Wolfram language you can easily set up a REST API call. And so essentially you need to know which URL to call it from. You need to know the ID of the element you want to call. And in this case, it's a GET call, and you need the access token, and that's all there is really. So we can set up the entry request, and now I can call it. So this is a live call to Contentful. So this has gone into the cloud and picked the data up from the cloud and has returned it as a JSON structure. Okay, and so that you can play with this in your notebook. I've added the same data. I've extracted the data into Wolfram language file. So I'll now load the entry again, just to make sure that we're all working with the same data. But it's the same structure. And let's show a little more. So this illustrates nicely what I meant beforehand was everything is sort of JSON based. So this is a JSON structure which has been loaded into Wolfram language. I'll get into the JSON format in a second. But what we can already see, you can see there's different fields. You have a title. So this is a blog post, obviously, about called Training Artificial Intelligence to Play the Beer Game, and so on. So there's a little bit of text. There's links to other posts and so on. So this is the data structure you get from the content management system. And we can take a look at how long it is, and it's actually not very long. It only has 3 entries at the top level. But if we look at the depth, then we can see it's very deeply nested. It has 31 levels. So this is a very nested. It's actually a very long blog post, and this is with lots of images and so on. And this is a very nested, deeply nested JSON structure. Okay, and you can obviously look at the the blog post online. And what we use the Wolfram language for is to generate, the idea was to not only provide the blog post as a blog post, but also to provide them as PDFs. And what we use the Wolfram language for is to generate PDFs. And you can look at our website. You can download the PDF, and now it was generated using Wolfram language. Okay, and now I go into the details of sort of how that works. So first of all, let's look at JSON structures. And that to me is one of the first little highlights, is that Wolfram language makes it very easy to deal with JSON, because JSON internally in Wolfram language is represented using as lists of rules. Okay, so the Wolfram language rule notation and JSON, and it turns out that JSON can one-to-one be represented using using rules, and that makes it very powerful, because you know how powerful Wolfram language is in dealing with rule systems, and so you can use all that power for JSON structures. So let's take an example of JSON structure before we get into the complicated ones. So typically it's just the tag and a value, and the tag and a value, and the tags can be nested, so the tags can have structured values, which again then are lists of rules, and so that's what a typical JSON structure looks like. And as we saw beforehand, they can become very wide and very deep. So let's just take this simple one for now. And so because Wolfram language has things like the replace all operator, it's very easy to extract parts of the structure just by, because this is a set of rules, you can sort of apply the tags, the rules to the tag you're interested in, and then it returns the element you want. So if you want the value of tag 1, you can just add in tag 1, replace all, and you get the value back. And that's sort of the basic principle. And so then what I did is to create, to wrap this into a function, because obviously sometimes you want to get nested structures, and I've called it JSON part, because it's much like the part function, but instead of using indices to go into the structure, it's using the tag names. Okay, so I've called it JSON part. So let's just define that function, and now I can call JSON part on my entry on the big blog post we called. And let's say now I'm interested in, so instead of using indices, I can use the path of the substructure I'm interested in. So in this case, I want to go first get all the fields, and then from the fields I want to get the title. And then when I hit that, I get back the title of my blog post from that data structure. And the same thing is if I want the subtitle, then I can go a step further and get the subtitle, and it takes that back. So as you can see, in this case, it's using Wolfram language is very, very easy to navigate through your structure. Once you've understood the structure, then you can easily find the elements you need. Okay, and so this little function, JSON part, is something we use all the time when it comes to working with JSON structures. Okay, so that was highlight number 1. Now let's look at converting that JSON, and now we want to take that JSON and convert it to a PDF. Okay, and it turns out that these JSON structures are sort of fairly complex, and one of the things these content management systems have to do, they have to allow you to work with rich text, because you want to have text with paragraphs in, with images in, you want to have bold text, italic text, and so on. You want to have bullet lists, you want to have headings. So the content structure in Contentful has to be quite powerful, and Contentful has its own rich text, let's call it language, rich text syntax, which allows you to, so when you type in the text, obviously you type it in a rich text editor, but internally it's converted into a rich text JSON structure. And that's what we want to take and convert into a Wolfram notebook and then into a PDF. Okay, so we need to be able to parse these rich text fields. And so we can take a look at what these fields look like. So let's get at the the content field from the entry we've already downloaded. And this again is already sort of fairly complex and long. So let's just get the first paragraph. Again, so then I can already start using pattern language here to extract the first paragraph. And I know that paragraphs have a certain structure, and they have a node type called paragraph. So I can use first case to get me the first paragraph. Okay, so let's do that. And so this is what in my blog post, the first paragraph looks like in the blog post, okay, as a JSON data structure, okay. And as you can see, in the end, when you've drilled down to the lowest level, these structures are fairly simple. So you always have a node type, you always have a data element, you always have a content element, and then it can be nested. So the paragraph in itself has text within it, which then again has content, which then again has a value, which is the actual text you're interested in. Okay, and so then once I've got all this, I can now scan through my through my data and see what elements, what node types are there in this document. And in this case, for this document, you can see there's 20 so-called asset blocks, 3 entry blocks, and 139 entry inlines. So those are probably the images because it has a lot of images. Then it has headings, hyperlinks, list items, and so on. So that's all these little substructures is the things we need to pass and then to translate into notebook cells. Okay, and you can already imagine things like heading is easy to map. You have list items, which you can map to items in Wolfram language. We have ordered lists, we have paragraphs. So you can see, you can already imagine how you could map these things to the corresponding cell types in Wolfram notebooks. Okay, so that's what the structures look like. So there's one little problem when it comes to working with JSON, and that is that it doesn't guarantee ordering. So as we saw the structure before, and you have tags and values, but JSON and also contentful, they don't guarantee that the tags and the tags are always going to come in a certain order. So it's an unordered list, and one day the tag 1 could be the first tag, and the second day it could be the last tag, let's say. Okay, so that means when you come to sort of searching through these kinds of patterns, you're searching through these structures, your patterns can be quite verbose, because you always have to go through every kind of permutation. Okay, because your structure could be node type, it could be node type, blah blah blah, and so on. Okay, and that's a bit of a hassle because you don't want to write these complex patterns all the time. And so the solution is to actually take the JSON, because we're not really interested in the order, and to pass that JSON and to convert it into a data type, which in this case I've called contentful rich text, which is an abstract data type, a symbolic data type we're defining in the Wolfram language, so that we always can, once we've transformed the JSON into those data types, then we have a fixed structure, which makes it much easier for us to deal with to pass the information. And this is very similar if you're familiar, for instance, with the symbolic XML or symbolic HTML that is built into the Wolfram language. This is a very similar thing. So what we've in a sense created is symbolic contentful rich text, okay, which allows us to deal with that in a very simple way. And this is actually quite simple. So you have here your rich text elements, and then I just write converters for this, which then allows me to convert the JSON structures, and I'll quickly do that. And then I get the same information back I had beforehand, but now I'm not dealing with JSON anymore. I'm dealing with these contentful rich text types. Okay, and that makes life a lot easier once you've done that, and which is, presumably also the reason why Wolfram language has symbolic XML, because you want to have a fixed structure you want to deal with. So the next big highlight is something that is known as multiple dispatch, and I'm sure most of you are very familiar with the Wolfram language, so you know about this. But to me, multiple dispatch in itself is a reason almost to use Wolfram language, and so it's not called multiple dispatch in Wolfram language. But as you know, in Wolfram language, you can create multiple definitions for the same symbol known as down values. Okay, and which of the definitions is used in a particular evaluation is always depends on the input parameters you use. And that feature of the language is known as multiple dispatch in computer science. And many languages don't have that. For instance, Python doesn't have that. Yeah, but which is a big shame, because multiple dispatch is a really very, very useful feature, and it's especially useful for writing ETL scripts. So let's just take a look at that in case you're not familiar with it before we get into the more tricky stuff. So let's look at a simple example. Say I have a simple list of data, and you can see here already that the data has different types. Okay, so we have a string, we have integers, we have real numbers. Okay, and we have lists and sublists. Okay, and the cool thing about multiple dispatch is I can define the same. Using the same symbol, I can define different functions. One function that just works for string, another function that just works for integers. But when I'm writing the function about integers, I don't need to worry about what the string function does and vice versa. So I can always concentrate on the function because I know exactly this function is working on a particular input set. Okay, and when I then apply this function to my list of data, then automatically you can see already what happens is the function maps over each of the data types, and if it's a string, it converts it to returns string. If it's integer, it returns integer. And because we're working with a symbolic language, we don't have any definitions yet for real numbers or for lists, and so this sort of stops there and doesn't do anything. Okay, because it doesn't know how to evaluate that. So now we can define another function for that knows how to deal with lists, and in this case with lists we don't want to transform that, we just want to wander into the list. So this is what that function looks like. We use an apply, and then a map, sorry, and then for the real numbers I just want to return actually I want to return this. Oops, just clicked the wrong thing. It doesn't matter. I wanted to return the string real, but it doesn't make a difference. Only a little example. So what happens then? Now it returns. So now obviously I can reapply the transform function, and now it converts everything correctly. Okay. So I think this illustrates with a very simple example the power of using of multiple dispatch, and that's sort of the workhorse you need to do when you're converting complex data structures from one form to the other. And so all we need to do once we understand each individual data structure, all I need to do is know how to transform the individual one. And I don't really need to worry about the whole big structure that we're dealing with. Okay. And so now if we then take this to apply that to our newly defined contentful rich text data types, then I can define a couple of functions, and they look a little slightly more complicated or more verbose than the demo I just gave you. That's why I wanted to illustrate the concept of multiple dispatch using simple functions. But this is essentially exactly the same. So now I have a function that defines how to convert rich text data types of type document. Then I have another function that tells me how to convert rich text data types of type heading, and so on. Okay, and for instance, here with the heading, you can see I can convert this into a text cell, which then contains a row of data because the text cell, because it could have, let's say, bold text in it or something like that. So it has to sort of pass into the detailed structure, and eventually, and so then it goes down through that structure. Then I have the same thing again for paragraphs. I have the same thing here for the demo. Because obviously I don't want to go through every single data type. I've excluded everything in the document that is in the document a heading, a text, or a paragraph, simply for the demo, and so on. So let's just define these functions. Hang on. There we go. And now I can take my rich text and convert that, and that is, in a sense, in a nutshell, all you need to do, because now we've converted the blog post into a list of notebook cells. Okay, so it's as simple as that. So now I'm just picking out the headings, the subsections in this case, and I've converted these into subsections. Okay, so this little bit of code up here is already in essence the complete parser, and all that is missing is parsing the other data types and converting them into the right cell. But as you can see in itself, it's really, really trivial. Okay, once you've set up the basic mechanism. Okay, and so then I can look at the text cells. So there's quite a few text cells, 144 as we saw previously, but then I can pick out the first one, and this is what the text cell that we saw beforehand in JSON now looks like as a notebook cell in this presentation. Okay, so I think that illustrates how easy it is to pull data from an API, to convert it into an internal abstract data type, and then to convert that, in this case, to notebook cells. But obviously I could be converted it into whatever I want to convert it into. I'm using notebook cells in this case because I want to generate a document. Okay, so that's that part. And once you've done that, the rest is in a sense super trivial because generating PDFs from a notebook is actually built into the Wolfram language. So now I just need to, from my text cells, create a document. So I can easily do that. So now I have a notebook. This has created a separate notebook object, which isn't visible because I've set visibility to false here. And now I can take that notebook, export it as a PDF, which I'll do right now. And then I can import it back so that we can look at the individual pages. So that this is the document we just generated, imported back into our notebook, into our presentation. And to illustrate, I'll just take the first page. And this is what the first page looks like. And note, all the code we use to generate this is actually in the notebook. I've presented every single line of code. So it shows how, in a sense, trivial it is to get started. Obviously, then the effort is in the detail because you have lots of different kinds of things. So, for instance, we haven't dealt with the lists and the numbered lists and the images and so on. Okay, we've taken only looked at a small part. But as you can imagine, it's just a question of adding more and more conversion functions. But actually, the basic logic is already there, and that shows how quickly it is to set something like this up. It's only a few lines of code. Okay, so that gave you a brief overview of how to set this up. And now let's look at. Oh yeah, there's one little highlight I wanted to show you because it's also something I learned on the way. We use quite a bit of. We have blog posts that contain mathematical equations, and we use LaTeX to do that, and on the website we present that with something known as KTeX, which is a package that can be used to present LaTeX on websites. But all these formulae, we want to also have them in our blog posts. Okay, and initially I thought I'd use that Wolfram language supports importing LaTeX, so I thought I directly import the LaTeX, but it turned out that wasn't really such a good idea because there's lots of different dialects of LaTeX, and in the end it turned out that wasn't a good approach, and we found a much better approach. And it's something I learned actually on the way, is that Wolfram language has its own little box notation for formulae, and many of you may know this already, but to me this was something I learned on the way, and I just want to present it here because what we do in our content management system, we have strings written in this box notation, which essentially can be used, is similar to LaTeX, that you can define mathematical equations, and then you can easily typeset them using Wolfram language. So you can import it from our content management system. So we have every equation that we use in our blog posts in Wolfram box notation in our content management system, and then we read it and then can generate equations from this. And this is actually very powerful, and so it supports everything that's in the Wolfram typesetting system. So, and as you can see here, we can have build equations with multiple lines and so on. So I thought that was a very neat solution to something that actually is in the end quite complex, and there are not that many systems that support generating neat formulae using into PDFs. Okay, so I think that was it from the code front. Let's just go to the next section. So that illustrated how to build the converter. But now the question is, how do you get that into production? And there's one thing that let's say using all this on the desktop machine and using it with Mathematica and everything works nicely. But how can we get this into production? And actually, it wasn't so easy to find the right deployment architecture. And obviously, we wanted to do something based on Wolfram engines, but now there's the enterprise private cloud. You have the Wolfram web server. You have the Wolfram engine. You have the Wolfram web server for Python. So there's quite a few different products out there. And actually, initially, I wanted to use the Wolfram application server, but that turned out to be a bit too heavyweight. Even though we use Kubernetes anyway for our websites, and for our other systems, but we decided that the Wolfram application server was, in a sense, too powerful for what we needed in this case. So in the end, we decided to go for a mixed architecture where everything is running on Kubernetes. but we use Python and a UWSGI web server to provide a web service which could be triggered from the outside to start the generator. Okay, but that web server then, whenever the generator is called, then starts up a Wolfram engine on the fly, which then calls the generator code and generates the PDFs. Okay, so the basic idea is here to not have the Wolfram engine running all the time, but it sort of starts up as a background process whenever the generator is called, and that way the web service can return straight away and say, yes, the generator started, and then the generator runs in the background, generates the PDFs and uploads them to a virtual file system. We use Amazon Elastic File System. We upload the data, and then we serve the files. Okay, so that's the basic deployment architecture. And as I say, it wasn't easy, but in the end, we found the right one. It must also be said we had a few hiccups on the way because the Wolfram engine initially wasn't generating PDFs. So that's something we're looking into right now. But that's more a problem of the Wolfram engine in the Docker container, so we're trying to figure that out together with Wolfram to see how we can get around that. But that's the basic architecture. Okay, so coming to the end, so what are the lessons learned? First of all, there are a number of implementation challenges we came across. Firstly, we're generating documents in multiple languages. SVGs, it turns out a fairly trivial thing that actually could have nearly stumped us. SVGs aren't supported. Importing SVGs isn't supported by Wolfram language, which is a shame because SVG obviously is the format nowadays on the web. But thankfully, there's a resource function called SVG import, which then came to the rescue, which is a wrapper for a Python library, which would have been the alternative approach for us. But so there, we're already using resource functions, so that became very useful. Then we're talking about a lot of blog posts here and a lot of thousands of images, and obviously we can't regenerate them all every time. So we set up a caching solution for the SVGs, and also an efficient generation system that only generates documents new if something's changed. So it's a delta generation mechanism, which in detail is sort of fairly complex because we have to pass through all the structures to see what's changed before generating. So those were the challenges we solved, purely from an implementation point of view. But we also had a couple of tech challenges, which, as I said initially, one of the things we wanted to test was how easy was it to get Wolfram code into real production environment. So first of all, one of the issues we run into, interestingly, is that generating PDFs using the Source Sans Pro font, which is sort of the standard font in Wolfram notebooks, doesn't work on a Mac. So we run into lots of encoding issues, which then turn out, once, initially we couldn't explain them, which then turn out to be a pure font issue. So as soon as we started using a different font, not the standard font, everything worked fine. So that's sort of a little quirk which cost a lot of time because we were trying to figure out what the problem is. Then the PDF generation isn't working properly just using the pure Wolfram engine. So that's a bit of a hassle, which we're trying to sort out right now. So that's a shame, because the idea of taking the code and then moving it onto any platform isn't quite working out right now. And we also found that when it comes to deploying something into production environments, what I call the edge of the Wolfram tech stack, that there isn't as much documentation as one would like. You know how wonderful the documentation of the Wolfram system is, but when it comes to sort of deployment architectures and using it in let's say production environments for non-scientific academic things, we found we had to do sort of quite a lot of pioneering because we couldn't find any documentation on that. So few how-tos on how to write production level code. Okay, and a lack of architectural blueprints. So I'm hoping that this little presentation may be a step in that direction to start creating blueprints for how to use the Wolfram tech stack in sort of non-scientific production environments. Okay, so that brings me to the end. I'm sorry I took a few minutes longer than I should have done, but as you can see, I find this topic quite exciting, and so I got a little bit carried away in the end. So thank you very much for attending, and if you have any questions, I'm happy to take those now.